Hello. In this first hands-on video, we'll implement and test the first version of DrawingApp, version 1.1. Okay, now before anything, I'll delete the git ignore file because I'm not using git in this video series. The first thing I do is create the necessary packages for our first version. So right-click on lib, write new package, and enter DM01 instance member variables. And do the same in the app package. So right-click on app, new package, DM01. Now I add the first version of my rectangle class, my library class. So right-click on DM01 in lib, new Java class, and enter rectangle. Press enter. First thing I do is add a little comment after the closing brace of the class. Now, as we've seen in the presentation about instance member variables, we have 4 properties we need to define in the rectangle class. So they are x, y, height, and width. All integers and public for now, more on public later. Now I put these properties in a comment block, instance member variables. Now, instance member variables keep the state of an object. You might come across synonyms like attributes, properties, or just data members. In the latter case, I prefer the prefix just data members with instance. Why that is will become clear in the video about class members when I talk about static. Okay, let's test it in the app subpackage DM01. So right-click on that package, new Java class, DrawingApp. Press enter. Now this is the application class, so it is a class that will be initially loaded by the Java virtual machine. And how do we tell the virtual machine that this is the startup class, so to speak? By adding a public static void main method. Now there is a shortcut in IntelliJ, PSVM, enter, so I'm using that one. Okay, let's use rectangle in the application class. So type rectangle, and IntelliJ comes with a few rectangle classes that I can choose from. Make sure you select the right one. Module 1 classes objects. Double click. By making that selection, IntelliJ adds an import statement above the class definition DrawingApp. Now, in this case, the import gives class DrawingApp access to the public instance data members of class rectangle, which is located in another package. I define a reference variable, rect1, and create an instance. Assign a few values to the properties. rect1.y is 20. rect1.height is 100. rect1.width is 200. Something I do on a very regular basis is make sure that my code is properly formatted. Execute a shortcut on the keyboard, but which stands for code and then reformat code. Now the default is, I think, Ctrl-Alt-L. I change it to Ctrl-Shift-F. So Ctrl-Shift-F to reformat the code. Next thing is to print out some values. And for that I'm using shortcut SOUF, print a formatted string. I'm not a fan of the println version. Printf gives you many more possibilities to print out data in a formatted way. So first property I want to print out is the x property, and then rect1.x. Copy paste. So y, height, and width, and then here as well y, height, and width. So let's run the application. For that I click on the green arrow in front of the class definition or the public static void main, either. Click and then select run. It's going to build my application, create an out folder, and down below you see a console which displays the properties of my rectangle. What is in the out folder? If I open it, well, this is where the actual compiled code resides. So IntelliJ creates the same directory structure as my packages. And if I open the lib package, dm01, you see a rectangle definition. Now if I click on that, I get a warning. You can accept this. And what it opens is seemingly a Java text file, but actually it is, as you see, the tab that was opened by IntelliJ, rectangle.class. So by building the project, all the .java files, which are just text, they are compiled to bytecode, and all the bytecode resides in a file with the same name as the name of the class, rectangle, but with the extension .class. What you see is actually decompiled bytecode. Now it is actually a bit more than what we typed, more in that when I talk about constructors. I close the rectangle class. Same has happened in the app sub package DrawingApp. Okay, that for the out folder. Now, why do I keep talking about instance member variables and not just member variables? First, because there exists something as non-instance or class member variables, which is what I'll talk about during the class member videos. Second, what I'll demonstrate now is that instance member variables are always tied to specific instances of a class, the so-called objects. And let me demonstrate that with the following code. So I go back to the DrawingApp, and suppose I want to create a second instance, assign different values to the properties and print them out. So I'm just gonna copy and paste. So copy, right click, Control C, and then right click or Control V, paste. Okay, now I'm going to change this variable instead of doing that manually. rect2, 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 etc. It's quite a lot of work, error prone as well. A better way to do this is to refactor the code. So right click on rect1, refactor, rename at the top, and change rect1 to rect2. And as you can see, all the reference variables are changed to rect2 within the scope of that variable. So I'm creating a new rectangle and assign different values to it. Let's use 30, 40, 300 and 400 and print it out. So run the values of rect1 and the values of rect2. What can we conclude from this? Well, that each object or instance, in our case we have rect1 and rect2, each object or instance has its own copy of x, y, height and width data member. Put another way, each instance data member, so x, y, height and width, is tied to a specific instance or objects, rect1 or rect2. I'll demonstrate that more visually in the third video about instance data members when I'll dive under the hoods. Now, time to draw your attention to a problem in the current implementation. Let's have a look at what is happening here. Suppose that I want to print the properties of rect1 after the instantiation, but before values have been assigned. So actually I'm interested in the default values of x, y, height and width. So we're going to print all those properties. Okay, let's do that. I copy these 4 lines and paste. Let's run it. So let's have a look at the outputs. What are the default values? They are all 0. Okay, so I've got zeros, I've got the values of rect1 and rect2. And suppose I want to do the same for rect2. And I hope you start to see what is happening. Every time I want to print out the properties, I need to execute these 4 statements over and over again. So this creates a lot of what we call duplicate code, because the code is very similar. Every time 4 lines, 4 lines, 4 lines, etc. The problem becomes more apparent if you want to, for example, change the output format. Let's say that all of a sudden, well, our customer is interested in having the information on the screen in uppercase. So uppercase X, uppercase Y, uppercase height, and uppercase width, the first letter. Well, I have to do this over here and over here and over here. And you see, this is only a small program, but suppose you have these code blocks
hundreds and hundreds of times. This is not the way to go. How do we solve this? I'll demonstrate that in the next version of our drawing app when I talk about instance methods. Thank you for watching. Bye bye.